Example, use vectors to prove that the line segment drawing between the two midpoints of the two sides of a triangle is parallel to the third side. So this is example we want to prove. If we have triangle ABC and we have the midpoint of AB and the E midpoint of AC, by using vectors we want to prove that ED parallel to BC. So we have here D midpoint of AB, so AD half AB. So AD directed line segment half AB direct line segment because they have same direction. And also we have E midpoint of AC, so AE half AC. So AE directed line segment half AC directed line segment also because they have same direction. And in triangle ABC, if we have BC directed line segment, so we can find BC by triangle rule from definition of addition will be BA plus AC. BA directed line segment plus AC directed line segment. And also we have in triangle ADE, if you want to find DE directed line segment, so from definition of addition will be DA plus AE. So if we want to find DA, we have AD equal half AB. So if you want DA directed line segment will be half BA. So DA will be half BA directed line segment, and we have AE equal half AC. So we have DE equal DA plus AE, and DA equal to half BA, and AE equal to half AC. So we can take half common factor. So we have BA plus AC, and we say that BA plus AC is equal to BC, directed line segment. So DE equal half CB, DE equal half the directed line segment CB. So they have same direction and they are parallel. DE is parallel to CB. And the norm of DE, directed line segment, equal half the norm of directed line segment BC, then the length of DE half the length of BC. Another example, we have here A 1 and 4, B negative 1 and negative 2, C 2 and negative 3. By using vectors, prove that A, B, C are vertices of right angle triangle at B. So in triangle ABC, if you want to find the two adjacent sides, AB directed line segment and CB directed line segment. So we have here AB equal B minus A, and we have B negative 1 and negative 2 minus A, which is 1 and 4. Negative 1 minus 1 will be negative 2, and negative 2 minus 4, negative 6. And we have also CB, B minus C, B negative 1 and the negative 2, and C 2 and the negative 3, minus negative 1 minus 2 will be negative 3, and negative 2 minus negative 3, so negative 2 plus 3 will be 1. So by using the rule of perpendicular, we'll make negative 2 multiply negative 3, x1 multiply x2, plus y1 multiply y2, negative 6 multiply by 1. So will be negative 6, but negative 2 times negative 3 equal positive 6, plus negative 6 times 1 will be negative 6. So positive 6 and negative 6 is equal to 0, which is the perpendicular rule. So AB directed line segment is perpendicular to CB directed line segment. So measure angle B will be 90 degree. So the triangle ABC is right angle triangle at B. Another example, ABCD is a square. If A equals 8 and 2, B is 3 and negative 1, C 0 and 4, find by using vectors the coordinate of B C. So we have here triangle ABCD. We have here triangle ABCD, and we want to find D by using the properties of squares. So we have AB is equivalent to DC. So we can write it as B minus A and C minus D. So we want to find D. So B, so will be negative D will be positive D to the other side, and we have here C minus B plus A, which is equal to C 0 and 4 minus B, which is 3 and the negative 1, plus A, which is 8 and 2. So D will be 0 minus 3 will be negative 3 plus 8 will be 5, and 4 minus negative 1 will be positive 1. 4 plus 1 will be 5, then plus 2 will be 7. So the coordinate of the point D will be 5 and 7. And if we want to find area of a square, we can find the norm of any side. So we can find the norm of AB. So the norm of AB, first we will find AB. So we'll find AB, which is B minus A, which is equal to 3 and the negative 1 minus A, which is 8 and 2. 3 minus 8 will be negative 5, and the negative 1 minus 2 will be negative 3. So the norm of AB will be negative 5 power 2, which is 5 power 2 plus 3 power 2 will be 25 plus 9 will be root 34 length units. So if you want to find area of square ABCD equal root 34 times root 34 will equal 34 square units. Thank you for your listening, and see you later.